today we are going to see 3-inch arch. Okay, and before starting with 3-inch arch, we should know what are the types. So before going to 3-inch arch, this is our main topic for which they are asking in essay 1. Okay, but before that, we need to understand what is arches and what are the types of arches. Arch is nothing but a parabolic structure. If I consider this is my parabola, so in this parabola there are 3 types. First one is 3-inch arch. 3-inch, as the name suggests, there are 3 hinges. First over here, second and third. Okay, if 2 hinge I am talking about, so here over here I have 2 hinges. Okay, and if I talk about fixed, then fixed is like this. My parabola will be having fixed structure over here. So what is different between fixed and hinge? So fixed, if I'm talking about a fixed structure, then it have vertical force, horizontal force and movement. Okay, but if I talk about only hinge, then there is horizontal force and vertical force. If I talk about roller, there is only one. Okay, so these 3 forces which we are considering over here. But when I talk about 3-hinge arches, we are going to study detail about 3-hinge arches. So let's see what are the types in 3-hinge arches. So if I talk about 3-hinge arches, there are 2 types. First one is parabolic, and second one is circular. Okay, now most probably they use parabolic. Reason behind it, we will be seeing that. Okay, but in that also we have 2 types. One is symmetrical and second one is unsymmetrical. Now, what is symmetrical and what is unsymmetrical? We'll show with the diagram. Let's see, talk about symmetry. Okay, when I talk about symmetrical, we know what is symmetrical. Symmetrical means if I cut the particular structure in half, then the both parts are going to be same. So if I see, it's something like this. Okay, this is my arch, my height h. Okay, from the crown. Crown is your topmost point, my crown. Okay, then let's consider this is the x structure. So over here, my height is y. Okay, from here, the distance is x from this particular structure, and this is 3 inches. Okay, so I will provide hinges over here, and over here we have 1 inch. Okay, L is going to be the length for this whole structure. You can consider a span. Okay, and for the formula of this, okay, we have seen in the song, we have solved it, but the direct formula is given. The formula is y is equal to 4hx L square into L minus x. So this formula you have to remember. This is for the parabolic structure in a symmetrical form. If I go for unsymmetrical, okay, what unsymmetrical is going to looks like, it's like this. Okay, one structure is over here. I have 1 hinge over here. Second one is over here. Okay, this is my top hinge. Okay. Height will be different. The main difference between symmetrical and unsymmetrical, there are the 2 halves are going to be different, obviously, but the main part is they both have different heights. Okay, this is h1, this is h2. Okay, similarly, we have L1 over here and we have L2 over here. Okay, so L1 is different, L2 is different, h1 is different, and h2 is different. So if I cut into this 2 halves, then it's going to give me 2 different arches. So it will be half span will be h1 L1 and second part will be L2 h2. Now if I use this formula for the same thing, okay, then it is given as L1 divided by root of h1 is equal to L2 divided by root of h2. This is derived. We have to remember this formula. Okay. Now, if I talk about the section, let's go to the next page. We talk about the section. Let's consider in my parabolic arch, I'm considering a section like this, and the force is acting over this particular direction. This will be my h. This is going to be my theta. Now, what we are going to do, we are going to resolve the forces. Okay. That will be V and the Q. So, what I'm going to do, I'm just going to use my similarity. Sorry, 3 equations that are summation fx, fy, and moment. Okay, so if I apply those, so we have a direct formula. Let's first resolve this. If I resolve this, it's going to look like something like this. Let's take a plane structure. Okay, let's consider this is my n, that is my force acting over here with the angle of theta. Okay, so if I resolve this, it is going to be this is V H. So I will resolve this into two parts. First one is vertical force and horizontal force. If my angle is theta, okay, then this is going to be V sine theta. Okay, this is going to be V cos theta. This one and this one. And if I talk about horizontal force, this is going to be my H cos theta. Remember, the angle with the theta is going to be sine cos, and opposite angle is going to be sine. So it will be easy for you to remember. Whichever one having theta will be with the cosine. Okay, that's going to be the resolution. And if I say there are two formulas, n is equal to, if I calculate n, so it will be v sine theta plus h cos theta. Okay, now I'm talking about this type of like direction, consider this direction. So v sine theta and h cos theta I consider as n, will be giving me the value of n. If I talk about q, q is going to be in this direction. Okay, this is going to be my q. So I'm going to add these two. So it will be as per the condition. If we see, it will be cos theta minus h sin theta. Now, why h sin theta is minus? I'm considering upward force as negative and downward as positive. So h sin theta will be negative. I got n and I got q. Okay, so this is going to be your resolution for the particular section. So if I talk about a section, what I'm exactly talking about over here is, if this is my one, one inch over here, second and the third. So not exactly every time you are going to get a force over here, or let's consider unit load over here and then UDL over here. So if they talk about, like, consider a section YY. If I'm taking this section as Y, Y, and they are taking this section as XS, then I have to find at that particular section what will be the forces. Okay, for those forces they have to